I appreciate the opportunity to talk with you about some other plays in the Permian Basin. And I was looking very quickly, and Charles, sorry I couldn't find the slides. I'll get those for you separately. Are there more things to do in the Permian Basin? And you bet, and I'm going to introduce you to a couple of those this afternoon. I think as the independents started opening up the Wolfbone play and you know, the talks that Bill went through and showed you some of the very early plays that were coming off the slope on both the east and the west side, those were primarily found by independents in Midland. And actually one of the independents actually lived in Tyler, and he commuted back and forth to Midland on a daily basis. And he got Henry into the play that Bill showed you on the western side of the Delaware Basin. And independents opened up all this. And that's always been the case. And in 2001, when Marlon Downey was president of APG, at his business conference during the national, he brought in all the top geologists from all the major oil and gas companies, and that was at the time that BP and Amoco had just merged, and some of that activity was going on. So it was really what's going to happen in the 21st century. And Herbert Hunt, who I was working for at the time, was supposed to deliver the talk for U.S. independence, and his wife Nancy told him during that same week of APG it was their anniversary and they were doing something else. And the good part of that story is I was in Herbert's office when he called up Marlon to tell him that he was going to have to back out, but Bill Fairhurst is sitting across my desk and he'd be happy to represent U.S. independence, which I was, and allowed me to add to Herbert's talk and really study what had happened. And in about a weekend I went in Herbert's office. I said, Herbert, I've looked at all the 10Ks for every public company in the United States producing oil and gas. I said, independents have found all the oil and gas. And he just laughed. And he said, Bill, it's always been that way. And I have a great diagram I had to do I do consulting for people on Wall Street. I finally put together a chart for them, and I said, look, when you're in this phase of exploration and the play's not opened up yet, and who do you look for? You look for the one and the two-man shops. And you look for those innovative guys that are doing the work to find those plays. And then once they've kind of made that discovery, of course, a two-man shop doesn't have the capital to get that developed, and it goes to the next size shop. So it goes to a company with 10 to 50 employees, and eventually that ends up in ExxonMobil's hands. And when Exxon bought out the Bass family last year for $6 billion, there was comments on LinkedIn, well, it's about time Exxon showed up. Like, this play has been going on for 7 years. I said, no, they're just right on time. They're right on time. You finally need that kind of capital to do the manufacturing that needs to be done on these plays that independents found. But independents found every one of them. And independents in Midland are not asleep. And if you're working the Permian Basin here in Houston, you shouldn't be asleep because there are a lot of things to take a look at. I'm going to show you what some of those plays are. Now my responsibility is the Bureau. I still do River Ford exploration, but I found I can do that in about 10 hours a week and go found something else. And River Ford, of course, is very active in finding these things and keeping them secret. Now that I work for the Bureau of Economic Geology, my job is to go out and promote these things and to share all my thoughts with you. And so there's some great exploration ideas here, I think. Comments I was looking for, I had a great quote from Bill Gates, and he talked about creativity. And he said, you talk to creative people, and I gave a talk, I think, at CIPES last July on creativity. And his thought is, creative people really feel kind of guilty about it because it wasn't anything magic to them. It was just the next level or the next step. And for those type of people, that's true. When you get to that level of creativity, it's like obvious to you, take these steps and go here and here. But people miss out on doing that. That's what that talk is. How do you develop good creative ideas to be able to get in these plays? And then the second quote from the next slide was what I added to that. And I said, you know, true breakthrough creativity is not common among most people. Everybody's creative. All animals are creative. People are creative. Animals use tools. People use tools. All people are creative. And their creativity can be enhanced. But there's an innate ability and skill that people have to be able to do these things. I think they're independent geologists. I think that creativity is more common in geologists than it is in the general population. I think that's why we're in our science that we are. Pure physicists and mathematicians are very linear thinkers. It's a very simple science. Now, when I say that, and I talked about that last summer, it is a simple science because it's very linear in its thinking. Geology, the reason it's so much fun for so many of us is you have to integrate so many different things. But when you integrate it correctly, you see things that nobody saw before. And I've told people, making money is not the fun part of a discovery. Now, it is for a lot of people, obviously, and it helps out. It helps out, but right, the joy of putting something together that nobody has done before, and then following it through. You have to sell other people into the process. You have to convince them of your concepts, and you have to sell them, and then you have to patiently walk through this process to get somebody to invest and get somebody to drill. And when you drill that well and you get those logs or you get those mud logs, and it proves the concepts that you've been working on, there's nothing more rewarding for that. Is there more to do in the Permian Basin? The Permian Basin's been dead 5 times during our careers, right? At least. Other basins have too. Herbert Hunt had worked in the Williston Basin for 48 years when I joined him. We made 12 discoveries in 18 months. New field discoveries people just didn't see. So I walked into the Permian Basin about 7 years ago and started looking at some of the projects that a company had done. They were backed by a PE group. They were $70 million in the hole. They were mostly projects that were brought to them by one group of people. They let that group of people go and said, help, what can we do? So I said, okay, let's look at the Permian Basin. So the first, I'm going to break this up in a couple presentations. This first one, and if you've seen this discovery talk before, it's not the same one. I never get the same talk twice. I've done this a number of different times, and so you'll see something different. These are all things I did as an independent geologist, now employed as someone, and I'll tell you how Riverford got involved along the way. The Wolfbone Discovery Team, of course, we usually don't do these things by ourselves. We do them with groups of people, and there are a lot of people involved in it, but these are the 4 people that I think are mostly responsible for that discovery. And by the way, M.L. Hansen is the granddaughter of Bruno Hansen, past AAPG president, and her father was president of AEPL. He went over to the dark side. All right, we're in the Permian Basin, and where we're going to start is we're going to start in the southern Delaware Basin. This is the acreage position that I finally put together there. That's not what it looked like when I came in. That's about 45,000 acres, but when I came in, that 45,000 acres was scattered in Pecos, a little bit in Reeves, mostly down in here in Ward County, and I'll talk about what we did with it. Here's the systems in the Permian Basin. Of course, now it's divided into a separate Midland Basin and Delaware Basin. In the Wolfcamp in the Delaware, the Wolfcamp is higher pressured. It's 2,000 feet deeper, and that's both good and bad for that play. The Delaware Basin is an asymmetrically shaped basin. You can see over on the right-hand side there, the right portion of that cross-section is the Central Basin Platform, and you go off the Central Basin Platform, and in 6 miles, you're at the center of the basin. And then it takes you 40 miles to go back up onto the west side. And keep that in mind when we look at this play, because without 3D seismic, I was happy with being on the basin floor where the dips are less than a half a degree, and I was happy being up on the west side because I knew we didn't have structural complications, but as an independent, we didn't have the money to acquire 3D, so I wasn't going to go over and play the west side of that basin in the play. All right, so how did this play get developed? And what was happening at the time is that there were 2 objectives that people were drilling out there at the time, and so I'm going to look at the shallow one and then the deep one. The shallow one are the Third Bone Springs sandstones, and a number of companies were drilling wells in these Third Bone Spring sandstones. There's a marker above here that identifies it, and we'll see the Wolfcampian immediately below. What was interesting about these is that these sands, where they're developed, have the same general geologic characteristics. They're 10 to 14 feet thick. They have 10 to 14% porosity, and there's really no difference between one sandstone and the next. But what we found is, and this cross-section goes from, I need to get a pointer that's working here, it'd be helpful. There we go. What we found is we went from south to north, is that in the south, the thicker sands were the upper sands, and horizontal wells went in these sands. And then as we went a little bit to the north, the better developed sands are the middle sands, and then finally these sands pinch out, these sands start to thin, and then up to the north, the thicker sands are the ones that we were drilling horizontal wells in. Now, these were horizontal wells that were drilled, and you had to stay in a 10-foot sandstone, so you can imagine that's pretty difficult to do, and there were some pretty expensive wells if you got offside. This map, I want to look at the bubble map, forget about the acreage position again, but you'll see that there's some yellow circles inside that yellow acreage there, and that's the type of reserves we were getting and recoveries we were getting. And as you can see, those upper sands, very minor producers. And as we started to march north, they were better and better. But what we're doing is continually going down section as we got those better and better wells. Well, if you look at an eland interpretation that Schlumberger does, here's the mineralogical interpretation, yellow being silica. Don't say sandstone, please. It's not in most places. Clays and organic material in pink and carbonates in blue. And if you look at these individual sandstones, there's one right there and one right there, you can see that they're filled with oil. But if you look at the shales immediately adjacent to them, they're very lean. Now, I talked with one major company, and they said, well, we type the oils, and we type those as Bone Spring oil. And I said, okay, when did you take the sample? And they said, the first day of production. And I believe that. During the first day of production, what you have stored in those sandstones may indeed be Bone Spring sand, but everything around is immediately pretty poor. So let's keep going down section. And as we go down section, here's the last sand. Now, it's not well developed here, but it's located right here. And then look what it's sitting on top of. Now, knowing that every basin in the world, and I worked a lot of South Louisiana before I started working in the Delaware Basin, I worked offshore a little bit. Every field that you go to that has multiple reservoirs in it, the most productive reservoir worldwide is usually the first reservoir above pressure. Why is that? It's where the source is coming from. That's where the oil is migrating from. And so as we continue to go down section, we drilled better and better wells, and we were sitting right on top of these shales. And no one was drilling those at the time, and no one was making that productive, although I was keeping my eye on those because I knew what Scott Sheffield was doing in the Midland Basin side. Well, how did I get this log? I got this log because we were drilling through the Wolfcampian shales to what's called the Wolfcampian sands. Now, the Wolfcampian sands are not really Wolfcampian sands, just like the Wolfcampian D is not Wolfcampian. And now that I work with Laux and Ruppel, that Bill had on his slide presentations, who are very good stratigraphers and academic stratigraphers, I have to be very careful. When you say Wolfcampian, you're talking about a period of time. When we talk about Wolfcamp in the Permian Basin, we're talking about a rock type and a formation. So why is the Wolfcamp D called Wolfcamp instead of being called Penn Sands or Penn Shales, which it really is? And the reason is because one of the major players, who's already been mentioned, was playing in the Midland Basin and sold themselves on not only a Midland Basin expert, but on a Wolfcampian expert. And they started drilling some wells in Penn Shales. And so when he was in New York, he couldn't tell Wall Street, oh, I'm playing the Penn Shales now. He wouldn't be thought of as a single folks player. So he called it Wolfcampian D. And that's how that name came about. Well, these shales, which were called Wolfcampian shales, which are actually Penn, was the play that Eagle Oil and Gas was making out in the basin. And where these sands are productive, they produce 1 BCF of gas per foot. So they're very productive sands. And these are the type of sands we were getting. Very good resistivities, great looking sands on cross plots. And we always had a 10-foot flare. As soon as we hit those sands, there would be 1,000 feet, and we'd have a 10-foot flare through the entire section. So the geologists that we had out in Midland loved these sands and thought we were in heaven when we drilled these sandstones. And so this is, again, what those sandstones look like in that section. Well, the first well that we drilled once I joined the group was this well here, and we're drilling for those Penn sandstones, Wolfcampian sandstones as they're called, and we drilled it in this well right here. We had 1,000 feet of that shale, 750 feet of sand. All high resistivity, all 10-foot flare throughout the entire section. I colored it all red. It looked great. Okay, so we found out a little bit later on, I'll show you in the story, the reason they have high resistivities is the waters are a little bit fresher than the rest of the section, so we therefore learned that. But it was very interesting. I said, okay, we drilled this well. We're drilling through the Wolfcampian shale section, which is about 750 to 1,000 feet thick out in here. Here's the structure on top of it, very generalized. And we hit this zone right here, and we're in a carbonate in the Wolfcampian shale, Wolfcamp shale, and we hit this and we put oil in the pits. And I just made a middle note of it. I said, well, that's interesting. I said, oh, that looks like a nice little fracture right there. And I thought that was great. The next well we drilled was 14 miles to the south. And 14 miles to the south, when I got to the same stratigraphic interval, instead of being in carbonate, it was silica, and the same stratigraphic position, I hit the same fracture, and we put oil on the pits. And I thought, that's interesting. Lithology's changed, same stratigraphic position, same fracture-looking thing. We then drilled a well 1 mile into the basin. We drilled 1 mile into the basin, and that fracture opened up into this. And we put, the engineers always laugh when I say 100 barrels of oil in the pits, because they say, Bill, it's more like 30, but there's a lot of oil. And put oil on the pits, and here's the mud log. And my concluding slide at the end of the day is going to be the same thing. If you give me any log, I get to choose one log to play any Paleozoic basin in North America. I'm going for the mud log every time. And that's what the mud log showed me, and this is what this section looked like. Now, we didn't complete it in that section. Those were just observations I had made at the time. The light bulb went off on my head when we drilled 1 mile into the basin and put that into the play. I said, what if I go 3 miles into the basin? What if I go 10 miles into the basin? I said, this is the play. The light bulb went off in my head. So what did the finance guys say? The finance guys said, the guy before you lost $70 million. You've just drilled 3 sub-economic wells. We're out. And I tried to talk to him all day. Light bulb just went off in my head. Doesn't work. You know, they want to show me the money, right? Show me the money. So after talking to them all day at 4 o'clock, when I finally realized that they weren't moving and I wasn't moving anywhere, we said, okay, if I could find somebody else to replace you, your 50%, can we keep going? And they said yes. So I called up Primex Operating. Some of you guys might know them, a private independent out of Dallas. At 5 o'clock that afternoon, I said, Tom, the owner of the company, can you get over here at 8 o'clock in the morning? He said, sure. I said, I got something to show you real interesting. They were with J. Cleo Thompson. The J. Cleo Thompson acreage ended up being what Oxy paid $1 billion for, and then they turned around and did another $1 billion sale right after that. That's 2 years down the road, so let's stay with this part of the story. Showed him what this was all about. He said, I'm in for 3/8. So we still have 1/8 missing. And as we're walking down the hall and I go into the owner's company, we're giving each other high fives. Great, we're going to keep this program going. We haven't lost it yet. And I said, okay, there's 1/8 left. I said, I think this play will work. I'll take a small part of this if you take the rest of it. And he looked at me in amazement. Do you really want to do that? Do you know what you're talking about doing? I wasn't saying an override, I said a working interest. And I was a working man. I wasn't an owner of the company. And he allowed me to do that, and so he took the rest of it, and that's how River Ford Exploration got in the game. So I want to go back to M.L. Hansen. So how did I determine where we were going to go in this play? The wells I just showed you one was right here, one was right here, and then we went a mile into the basin. So I asked M.L. Hansen, I said, well, please go back and isopack that shale, just the shale section for me. That's all I want to see. Wasn't a nice pretty map like this. First year geologists, I don't let them work on their computer. They get a computer so they can do emails. I don't allow them to work on a computer. I want to work with them. I want to see that they can draw maps, isopack maps, structure maps. Once I know they can do it, then I let them have a computer and use geographics and other software programs like that after that time frame. So she drew this by hand, and before it hit my desk, I said, that's the story. This is the whole story of what the play was. So what did I see? I didn't see these pretty colors, of course, but what I knew was this is 1,000 feet of shale. That's plus 50 feet, that's minus 50 feet, but everything in here in the basin center is 1,000 feet thick. And here's the well where it went 1 mile toward that basin, still not at this line. I get to this line, and it goes from 1,000 feet, and in about 5 miles, I go from 1,000 to 750. Very consistent isopack through here, very consistent slope. So I said, that red line right there is it, guys. That's the basin floor. That red line is what it's all about, and I'll show you some things that we confirmed that it was all about. And the first one was, and I'll show you what the stratigraphy looks like. This is all the silica that's deep in the basin, high TOC percentages, and these are the carbonate intervals that come in between. You've already seen that on a log. Well, in an imaging log, this is what the carbonates look like. And the carbonates, as you can see, individual parts right here. That's an individual class. They're not round, but they're rounded, and they're all shelf material. And they're floating in a carbonate matrix, sometimes in a silica matrix. This is 1 foot on an imaging log. So look at the silica beds right in through here, not even millimeters thick. and they vary by individual zone and loaded with organic material in the center of the basin. So I said, okay, let's confirm that interpretation. So we took this carbonate, not the one we were looking at before is this interval. Now we're looking at this carbonate interval. So let's isopack this interval, and then there's that red line on the slope margin. Now I'm arguing with Roops and Laux about this right now, because they're if you type in Wolfcamp, if you Google Wolfcamp, the first 7 papers you're going to see are Scott Hamlin, who now works for me at the Bureau, Ruppel, and Laux. So they've been working this section for 30 years, but they've been working it up on the outcrops on the slope. So we argue about whether that is a point source. It looks more like a line source to me, parallel to the slope lines. The whole idea is this material coming off the shelf, once it comes off the shelf and it hits the slope, it's not going to stop on the slope, because if it got there at a certain acceleration, the slope's at constant angle, so it's going to stay on that slope till it hits this red line here, it hits that red line, it deaccelerates, and it deaccelerates, and it dumps the section all out in here. And so that was a reason that I wanted to be in the deep portion of the basin. This is from Passy, and what this is, and I read a couple master's theses about it, is this is the deep portion of the basin. This is where the silica is being deposited. And where the silica is being deposited, it's mostly from sponge spiculites and radiolarians. So this is not silica that's coming from outside the basin, it's silica from inside the basin from the organic material. And then the soft part of the organic material is being preserved, and it's not being destroyed when it gets down to the basin floor. That's the slope section in through there. So that was kind of the story. And so I said, okay, this is the sweet spot. And I was also vice president of the land at the time. So I said, I want to be here. I don't want to be 45,000 acres scattered over 3 counties. And so I made trades and did everything we can do to get ourselves located in this, and that you've already seen the land position that we're going to end up putting together. One of the more interesting ones is Chesapeake and Anadarko were in partnership. Now that is now an Anadarko Shell partnership north of this area. And at the time, Chesapeake had 59% of that partnership and Anadarko had 41%. So we went to Chesapeake and said, would you be interested in selling your interest? And they said, no, we're not interested in selling our interest, but they didn't have a successful program out here, but we couldn't buy it. So we went to Anadarko, and Anadarko said the same thing, and both companies were saying, well, you know, we're kind of the same size, we're kind of arguing about how to get operations done out here. You know, you've probably read some of the Shell Anadarko dealings going on right now. It's very difficult because who gets to operate is the one that proposes the well. So it's almost a race to get out there and see who can do most. And Shell wants to sit back and study, and Anadarko wants to go. So that was the kind of relationship they had with Chesapeake. So, but Anadarko said, sure, we'll sell you our 41% interest. So we bought that, and I had acreage up in Ward County where we were drilling very expensive third bone spring wells that we couldn't keep in zone. So I traded out of some sections up there with Anadarko. And then we went back to Chesapeake and said, okay, well, you're our partner now. Would you like to hear about what our idea is? And they said, no, we don't want partners, so we'll sell our interest to it. So I got 100% of the interest by doing that, and that was a big part of it, and then we leased the rest of it. We leased the rest of it from between $50 to $500 an acre. By the time, as you all know, those acreage prices got up to over $50,000 an acre. So it's more than 10 times uptick on that sale. And so that's the acreage position that we ended up putting together, and that's how we got that block of acreage together originally. Well, when I started looking at the production area, and here's approximately that red line, when I started looking at bubble maps, I realized, oh, those bubble maps aren't exactly like I had expected that they would be. There's a slight bend to them, and that's how it looks on my isopack map. That seemed to be the better producing wells seem to be within that red outline there, not the exact north-south circle that I had. And so we looked at the structure map, and once I look at the structure map, if I don't glean exactly what I want out of there, the first thing I always do is say, okay, do a trend surface, I'm going to take a derivative of it, and I'll get the second derivative. That's the trend surface map that ML made for me, and then that's the residual, and that is right through here on that residual map of where that best production was. And so then that influenced where we picked up acreage after that point in time. And this was a little bit later, and you can see those bubbles still have that same type of orientation down there in Reeves County. So what else did we do while we were doing that? We were drilling vertical wells, and I drilled the first horizontal well in the Wolfcamp section in the Delaware Basin. But before we did that, we went out and we drilled 24 company-operated vertical wells. And all those vertical wells were they were at best singles. They really weren't boomers economically, but we were completing them from the Third Bone Spring sands all the way through that 1,000 feet of shale, and we actually were starting in the sandstones in that lower interval. And the owner was patient enough, and it was allowing me to use those wells to collect information and taking sidewall cores, taking whole wall cores. We ran every tool that Schlumberger, we were using Schlumberger primarily at that time, every tool that they had. Once we identified that we could do a petrophysical analysis and we could drop off sidewall cores, we dropped off sidewall cores. Then a couple wells later, we recognized, oh, I don't need to do an eland anymore. I can use just my basic 5 curves, and I can do very good petrophysical evaluation. So the owner was very patient and allowed us to do science. Same time, the engineers were running production logs, and the production logs, and they did the same experiment with production companies. They wouldn't tell them how much we were producing a day. They'd go out and do a spinner survey, come back with the results. And there was one company that ran spinner surveys that came within 5% every time of what we were actually producing and could tell us what intervals we were getting oil and water out of, and so we stayed with that company. Now this is an accumulation of 12 different spinner survey runs. This is the Campion Shale section right here. This is actually the Third Bone Springs interval right here. And we average those together. Now what we do is, the advantage of the Delaware Basin is that it's higher pressure, and so the first 6 months we produce up casing for 6 months. In the Midland Basin, you can't do that. You drill the well, you log it, you set casing, you perforate it, you frack it, and then you see what you have. In the Delaware Basin, you perforate it, and you frack it, and you stand back and just watch it flow for 6 months. And when the pressure would drop down, we'd put a spaghetti string in, it produced for another 6 months, and we'd never have to put any kind of artificial lift on it. So that was one of the advantages of the Delaware Basin. Well, this is an average of all those intervals, and you can see the blue is water, and the green is oil. Well, here are those sandstones that look so good on the logs. And here's the amount of hydrocarbon we were producing versus that water. And here's where we're producing through these zones. Here's the Third Bone Springs. Now what's interesting is 3 of the wells, we ran spinner surveys, and when we ran them right after production started, we weren't getting any production out of the Third Bone Springs sandstones. We'd come back 6 months later, and up to 30% of the production would be coming out of those sandstones. What was happening is you were drawing the pressure down in some of the higher pressure Wolfcampian. That would allow the Third Bone Spring sandstones to flow, and that's the reason we started getting represented in this section. But look at the concentration difference in oil. Now there's still a lot of water, and we're working with companies to explain that water. I'll tell you the bottom line on the water. It's very immature. Every rock in the world is originally waterway. Even source rocks are waterway. And what happens is you generate hydrocarbons, you drive out the water. Well, these are so immature that you've driven out some of the water, but you haven't driven out all of it. So what I keep telling people is come back in 40 million years, because there'll be a lot more oil here than there is today. And that's why you get so much water. And the engineers after 3 months would say, okay, we've kind of equalized on water, when's it going to stop? And I tell them, never. You're always going to be producing that much water because that's what you have in the rock. Neat diagram that Daryl Lohofer actually put together, so I won't take credit for it. And these are the, and if you see yellow, that's sandstone. And when I say sandstone, I'm talking about grain size. Those are sandstones. The green are resource plays. So there's the Wolfcampian section, 1,000 feet of Wolfcampian. Here's some other resource plays in the Bone Spring section. Here's the Third Bone Spring sands. So, and what these boxes are showing is showing where the wells were being completed. And if you see numbers, it shows how many stages per interval we had. So look at the wells we were drilling early on. All the concentration was down here in these sandstones. 1,000 feet of sandstone, and we're putting up to 2 stages in some of those sands, and we're getting mostly water back. Now, every once in a while, we complete something in the resource play, but you can see there aren't very many completions in that resource play. There's where I drilled that 3rd well, which we're actually drilling for these sandstones. So what we did is when we plugged this well, and that's what that black symbol means, there's a bridge plug right there, that's actually this well. Then we came back up and just did from the base of the Wolfcampian Shale through the Third Bone Spring sands. Now you can see that we went through here, and we hadn't learned our lesson yet, but at least now we're completing up and through here. So these red lines are what I call the aha moments, where we said, okay, let's start dropping these off, let's start focusing on here, but I couldn't get everybody to give up on this yet. And you can see that now we start gradually giving up on that, And then you can see the darker boxes with the higher numbers. Now, everything we did from that point on was from the base of the Wolf Campion Shale up through the Third Bone Springs. So when did discovery happen? Well, somewhere between there and there. Don't know, I can't tell you exactly which well it was, but that's what it did. And and by the way, after I drilled 8 more wells, then the finance company came back in and said, we'll take our other 50% interest back, thank you very much. But by that time, I'd earned interest in 7 sections, so I was happy enough with that. And this, I love this diagram. Now remember, these are vertical wells. These are IP rates, 60-day IP rate numbers. And so these lines were those aha moments you saw before. And you can see, what I like about this was, this trend line shows we're learning as we go, which I love to see. And that shows we're learning almost at the same, not quite the same rate, but up here we're learning at almost the same rate. This was, we're drilling some wells in a different geographic location, which was not my primary target. So, a little bit of a drop in there because we were going from A rock to B or C rock, but they were increasing. And this is about the time when we drilled the first horizontal well, after we had all those learnings in place and we knew what we were doing. During that whole period of time we're planning, okay, where exactly do I want to drill the horizontal well? And we're doing a lot of things to determine what that was. So here's the potential of the whole thing. Right now, in the Delaware Basin, they're mostly focusing on the Wolf Campion A. In the Midland Basin, they're concentrating on the Wolf Campion B, and I'll show you the reasons for doing that. So here's the production curve for Reeves County. Here's when I came into the company. You can see the little uptick from the Third Bone Springs horizontal drilling. So when I came in, it was right there. And the entire county was producing 3,000 barrels of oil a day in the entire county. Talk about the Alpine High being a stretch. When I drilled that first well, we were 15 miles from any production, further west than any production in the Delaware Basin. So the smart thing that I learned from Herbert Hunt was Jake Leo Thompson was flaring gas for the whole first year until they got pipelines there. One of the things I learned from Herbert is don't you dare put one molecule into the atmosphere. So we put in our own pipeline system. We dug one trench. One company put a gas line system in, the other company put a water system in, and we owned them both. And so that came out to be great when we went to the sale, because we actually ended up with a higher multiple selling our midstream assets than we did from the E&P assets, but we were an E&P company. And so what happened? So during that period of time, we started at 3,000 barrels, and this is monthly production, so divide that by 30. And today we're producing about 300,000 barrels of oil. So that's the magnitude increase that play has had in just that one county. All right, I want to spend a little bit of time, and you've probably seen it, this condensed shale section. I'd worked the Monterey in California. There's a condensed shale in the Monterey. In the Monterey, there's a lower Monterey, which is mostly carbonate. There's a condensed shale, and the upper portion is mostly silica. There are production differences between those two. Had enough learning to know these condensed shales were very important. And again, you can see this is the same mud log that we looked at before, because there's the oil that we put on the pits in that fraction, which became shale. So this is from Walter. He's here in town. Many of you probably know Walter. And this diagram is a little bit inaccurate, and I'll show you what some of those inaccuracies are. But this is a good model for us to do, and you can do the reading up there. Here's the condensed shale, and here's what's important about all those. Is that condensed shale, it's condensed not because it's been squeezed, because it represents a lot of time. And what it is that's the maximum flooding surface. So when you come to the condensed shale, that's the maximum flooding surface. You've drowned it out all the basin margins. You're not getting sedimentation into the basin. You're getting very high concentrations of organic material, not because there's more organic material, just because the concentration for the amount of time is much higher. You're getting much less dilution of sediments with that. So you have a low stand facies, then you get into this upper systems tract, as Bill talked about. You get the maximum flooding surface, and then this is the upper portion of the Wolf Campion, which is called the Wolf Campion A, which has more organic material than this, and we'll look at some of those differences. When you're in the basin floor, there are several shales that you look at that you say, well, that could be the condensed section, that could be the condensed section. But there's one that I can trace from Alpine High in the southern Delaware Basin to north of Lubbock in the northern portion of the Midland Basin. That is the maximum flooding surface, and it's very important to be able to identify that. So again, as I said, that's the Wolf Campion B through D. That's the condensed shale, which is at the base of the A. The same one in the Delaware Basin and the Midland Basin, and that's the Campion A up at the very top. So this is a log actually up on the shelf. And in the Campion A and the Campion B, these are actually sandstones instead of being those very fine silica beds that we took a look at. But there's my maximum flooding surface right there. And so I can trace that all through the basin, and you can use one type log to do it. So what's the difference between this low stand facies and this high stand facies? Just very quickly as we go, and I'm going to go geologically now. You know, why do we call the upper one A? Because that's how we drill it, not how it was bothered geologically. Geologically, we should have the lower one being the A, right? But that's the D, that's the C, that's the B. So as we go along this arrow right here, we're increasing TOC as we go up section. We're getting higher and higher flooding surfaces. Silica sedimentation is mixed. Allochthonous outside the basin or transported sediments with autochthonous or in the basin sediments. Clay is illite, and there's up to 15% chloride. Actually, there's up to 30% chloride, but on average, there's up to 15%. The RT is very much lower, as we have lower TOCs and higher clay contents. And I saw this on Bill's diagrams too. You have a separation of the density neutron curve. So when Bill was showing the landing zone in the Fayetteville shale, you'll notice that the lower shale had more separation in the density in the neutron logs, which tells you there's higher clay percentages. In the zone where he was drilling, the average porosity was just the same, but the density of the neutron were closer together, which tells you there's less clay in that interval. So you can use those logs to identify that. And then finally, down here, the carbonates were those big debris flows I showed you. The carbonates that we see in the A are very distal, wispy looking, very fine grained carbonates. So I know I'm in the high stand facies when we look at that. In the Campion A, we have the highest TOC concentrations. Again, it's very slow sedimentation. We've drowned out the sediment source. The silica sedimentation is dominantly autochthonous, or these sponge spiculites and radiolarian tests that we were talking about. The clay is illite. There's no chlorite in there. And the carbonate is that wispy little distal carbonate in it. So you look at it, and it has the same percentages of carbonate, but the carbonate are very different looking. So we talked about fractures earlier, and here's what's very interesting about this. This is a vertical well with an image log with fractures that are at 90 degrees to 85 degrees. I was amazed drilling a 4-inch hole, I saw any fractures, because the fractures are the same orientation as the wellbore. Again, here's 1 foot. When I saw all those fractures, I knew we were in a play. And the other part about them is you can see from this orientation that the orientation of that fracture is all the same, And these were some of the things that we used to determine where we were going to drill. And once I had a couple of wells together, I identified, okay, we've got a dominant fracture system that's oriented at 120 degrees, and that's the upper plot, and this is the Rose diagram of that. So our least stress direction is in this axis. And so I want to intersect as many of these. The question came up before in the fracture system, what about drilling perpendicular fractures or parallel to them? The studies have shown that if you drill within 35 degrees of perpendicular, your production is pretty much the same. Whether you are actually perpendicular or you're off at 30 degrees or so. Once you get over 35 degrees, the more parallel you are to fractures, the lower your production rates will be. So that's why you want to be as perpendicular to those fracture systems as you can possibly be. There was one zone, though, that had the dominant fracture pattern that you can see right here, and then it was offset by another set of fractures. So that's a fracture network. And this fracture network is at 60 degrees to that, which is a shear angle. So I was happy about that too. It's telling me it's a shear angle. The fact that these are, and I had confirmed this with Wally Dow. Many of you know Wally Dow is one of the premier applied geochemists, worked for Cimarex. He passed away last year. Confirmed with him, I said, I'm seeing all these fractures, and I'm in a high pressure system. And as soon as I get out of the shale and I go up into the Bone Spring, I get intermediate pressures for about 100 feet, and then I'm back in normal pressure. When I'm below that shale, I am getting normal pressure. So I suspect that what's happening geochemically is that kerogen converts to oil. It has to expand. And if I'm trapped with lateral seals, top seals, and bottom seals, and I'm trapped vertically, it's not going to be able to go anywhere because I'm in very tight rock. So the temperature stays the same. The space doesn't change. I was smart enough in my school chemistry to remember that formula said the pressure has to go up. And geologically, that happens very quickly in a geologic period of time. That happens and the pressure goes up by several thousand pounds. Well, what's the geochemistry doing? The geochemistry is doing exactly what the engineers are doing when they fracture a reservoir. But the geochemistry is what fractured these reservoirs. And we know that because of the angle of the fractures. When you get geochemical fractures, these are at 85 degrees. If you remember that Rose diagram, the average dip in there is 85 degrees, and those are characteristic of geochemical fracturing. So the TOC did for us what the engineers are going to come back and do later on. So those are some of the differences we see as we look through the differences between the B and the D and the A. So that's why the A is the current zone that's being focused on in the Delaware Basin, because it has the highest organic material, it has the best fractures potential, and has the best recovery. So companies are actually drilling two wells or two different zones in the A. They're drilling an upper Wolfcampian A because it's about 300 feet thick, and they're drilling a lower Wolfcampian A. And they're also drilling B wells secondly, and then D wells. And there are C and D wells that are as good as the A wells. But on average, the A wells are the best wells, and on average, the B wells are the next C, D as you go down section. So we can see some of the same things. I like Bill's logs a little bit better, but what I'm looking at, here's my density curves right here. So I'm looking for separation, and this is, by the way, the Wolfcamp A and the Wolfcamp B. You can see there's carbonate through there. And look up here in the A, there's actually more carbonate in the A than there is down here in the B. But this carbonate is much different. Remember, the carbonate and the debris flows had very low TOC material. This carbonate has higher TOC materials in the wispy portions of it. So I look for areas that have separation, that have higher clay. Those aren't good drilling targets for the mechanics, as Bill showed. Where those curves might have the same average, but they're on top of each other, that mechanically is more a better zone to frack and to drill into. And so we can see some of these things on the log, and you can see the differences between the A and the B that we talked about in those upper diagrams. So that's how we discovered the Wolfcampian A, or the Wolfcampian play in the Delaware Basin. It's been, I saw somebody, World Oil just came out with their map, and I looked very closely at what they said about the Wolfcamp in the southern Delaware Basin, and they said, well, it started out as a vertical play, and we have yet to see if it works as a vertical play. And I was just shaking my head. I mean, we've known since 2011 when we drilled the first horizontal wells in through there. I also recently, and going back on what Bill's talking about, so we're now moved out of this exploration phase and holding acreage phase. We're going into the manufacturing portion of it. I'm participating in some of the Noble wells. By the way, what happened with that is after we drilled that first horizontal well, the PE company came back in and said, okay, we're at the end of the 5 years of this fund. There's 30 companies in this fund. 20 of them have already sold. We want you to sell. Well, the story was I brought Primex in. Once we drilled a couple wells and we started to make the play economic, Primex begged us to go over to Jay Cleo, whose partners were Browning and Patriot out of Midland, and said, please come show all these other companies what you're doing. At that portion, the acreage was kind of locked down, so we said, okay, if we get other companies doing it here now, it's going to rise, the water's going to rise, everybody's going to float a little bit higher. So that was our theory. So we went over to them and we showed them what the play was all about. That's how J. Cleo Thompson started doing those completions also. So in late 2011, the PE company said it's time to sell. I said, give us 1 more year, because right now we'll do very well. The industry, our neighbors understand, but the industry doesn't understand this play yet. Give us 1 more year. We'll get some press. It will get really big. They said, no, don't do it. So we sold to Comstock, who Comstock then kept it for 1 year. And they're the ones who sold the Rosetta. And they doubled their money in 1 year. And we doubled our money in 5 years. So we would have had a 5-time uptick had we waited that 1 more year that we requested to do that. River Ford and Primex didn't sell when Eagle and all the financial partners sold out. So I stayed in play. As far as I know, River Ford, Primex, and Cheyenne, who's a non-op out of Oklahoma City that probably a number of you have worked on, the only 3 companies that were in that play as part of the discovery that are still in that play. So Noble now is drilling their first multi-pad wells. We just drilled the first 3 wells, drilled one in the Wolfcampian C, one in the upper Wolfcampian A, one in the lower Wolfcampian A, completed them with, they were 2-mile-long laterals, completed them with 4,500 pounds per linear foot. So do the math, Bill. We got a couple hundred tons of proppant down in there, and those wells in the first 3 months paid out about 40%. We're currently drilling 5 more, and we have 4 AFEs sitting on the table. Well, that's kind of the discovery story and why I switched slides. Are there any questions on the discovery of the Wolfcampian Shale?